the main lowered the coming hurricane. And far away to seaward hung the cloud rack like a pall.
For hurricanes, these are the darkest times. In the last 30 years, the number of the most intense has doubled, and there's more to come.
Good morning, folks. As you've heard, NOAA, with its National Weather Service, is predicting a very active hurricane season.
Hurricanes naturally process more energy per second than 10 times the bombs dropped on Nagasaki. What chance could we humans have of doing anything useful?
With global warming stoking the waters that fuel hurricanes, and with the billions of dollars of damage wrought by these megastorms, is there any way to control them?
There is a possibility to control hurricanes.
While the scientific establishment doesn't think so, there are a few mavericks who think it can be done.
Taking the surprise out of hurricane season, presented by Science at NASA. Prior to the 1960s, the biggest storms on Earth could take people by surprise. Someone standing on a beach in Florida might not know if a distant bank of clouds was a routine squall or the harbinger of a powerful hurricane. The space age changed all that. Satellites orbiting the Earth can image, probe, and track hurricanes, alerting forecasters and laypeople alike to storms in the offing. In recent decades, the introduction of supercomputers and physics-based models of storm dynamics, combined with satellite, airborne, and surface data, have pushed the accuracy of forecasts issued by the National Oceanic and Atmospheric Administration, NOAA, to a new level of precision. As forecasters have improved storm tracks, however, an area of forecasting has lagged behind, predicting the intensity of storms. In other words, how strong will the winds be blowing when a hurricane makes landfall? Scott Brown, hurricane expert at NASA's Goddard Space Flight Center in Greenbelt, Maryland, says, from 1990 to around 2010, there wasn't much improvement in the accuracy of hurricane intensity forecasts. In the last several years, we have started to see drops in intensity forecast errors. This can be credited to a number of factors, including better measurements from satellite and airborne platforms, improvements to the physics and numerical weather prediction models, and improved methods of ingesting NOAA and NASA data into models that describe the state of the atmosphere. An important part of predicting intensity is seeing what's going on deep inside a storm. Evaporation of water from the warm ocean surface powers hurricanes and causes them to intensify. Hotter sea surface temperatures at the base of a storm, therefore, can load a hurricane with more energy. On the other hand, wind shear can tear a storm apart, causing it to weaken. So, how do you collect data from inside a giant storm? First, you can fly right into it. In recent years, NASA has sent research aircraft directly into or over storms as part of the Genesis and Rapid Intensification GRIP experiment in 2010, and the Hurricane and Severe Storm Sentinel HS-3 mission from 2012 to 2014. These aircraft were flown to investigate the formation and intensification of storms. Operational airplanes, such as NOAA's P-3s and the Air Force's C-130s, are hurricane hunters and fly missions into the heart of storms to collect valuable airborne data sets. Additionally, NOAA's Sensing Hazards with Operational Unmanned Technology, or SHOUT program, utilizes a NASA unmanned Global Hawk aircraft to observe and predict high-impact oceanic weather. You can also get a view from an eye in the sky. The Global Precipitation Measurement (GPM) Core Observatory, a joint mission between NASA and the Japan Aerospace Exploration Agency (JAXA), launched in February 2014, and carries instruments that show precipitation location and intensity at higher resolutions than were previously available. Microwave imagers, such as the one onboard GPM, can look through the cloud tops to observe where and how much precipitation occurs. Additionally, GPM's dual-frequency precipitation radar provides a 3D view of precipitation structure. Dahlia Kirschbaum, a deputy project scientist for GPM, says, "Images from GPM and similar sensors are posted on the internet in near real time, so forecasters can immediately see the latest data." An upcoming NASA mission aims to improve storm intensity forecasting even more. The Cyclone Global Navigation Satellite System, CYGNSS, is scheduled to launch in 2016. CYGNSS's 8 microsatellites will utilize Global Positioning System (GPS) signals to make surface wind measurements. Direct GPS signals will pinpoint CYGNSS observatory positions, while GPS signals reflected off of the ocean's surface will indicate wind speed based on how much the winds rough up that surface. The stronger the winds, the rougher the ocean surface. CYGNSS will be able to measure winds in heavy rain regions inside the storm, where current wind-sensing satellites have problems, and will provide much more frequent observations compared to the once or twice-a-day measurements from current sensors. Earth-orbiting satellites, helping take the surprise out of hurricane season since the 1960s. For more information about hurricane season in ever-improving detail, visit science.nasa.gov.
Makushri, that's the old boxing plants. The river is passing inside Makushri estates. If you look right up, that's the river they're coming down from right up. Ooh. So many people came to see what has taken place at Makushri. People. Oh my God. Hey, there's a river. Hello. Hi. Oh, this is the bridge. This is where the bridge has broken. So many onlookers. You good? You good? Okay.
As you may all know, preparedness is very crucial to the Department of Defense. From emergencies and natural disasters to homeland security threats, our nation prides itself on readiness. Everyone needs to understand that they all have an important role to play when it comes to emergency preparedness. With hurricane season rapidly approaching, the Navy is kicking off its 2015 HURREX-CG exercise. This exercise will provide Navy personnel insight on how to respond to the threats of tropical storms and hurricanes. To become fully prepared for such disasters, sailors are strongly advised to start creating their own emergency kit to suit their needs in the event of a storm. Familiarizing yourself with your region will help you formulate a plan of action and prepare you to deal with these storms before they even happen. For more information and preparation tips, check out ready.navy.mil.
Well guys, there's our house. We survived Earl. There's the back end of Earl. Still looking pretty black as it heads for Guatemala and, well, through Guatemala and into Mexico. We're going to pan around. You see nice sunny skies coming. But apparently the danger is not over yet. The river is rising and I'm on my way down now to take a look at the river. The guys were just going around with a truck with a PA system on top warning all of the people that are by the river to evacuate. So it's a good little lesson that a lot of times it's not just the wind that's a factor in these hurricanes and tropical storms, but the rains that came. We were expecting to get 8 to 12 inches of rain. I don't see a lot of flooding around Bullet Tree, so I think by the time it crossed the country it probably petered out a little bit. But all of that rain is collecting in the river and we're going to head down now and see what's going on at the river. Okay guys, here we are at the river. If you look at the bottom of this telephone pole it says vote, and usually underneath it, running down the pole, it says Silva, vote Silva. And that's usually 8 or 10 feet up in the air. Where people can see it. So you can tell that the water at that point is 8-10 feet higher than it normally is. So we pan over to the riverside restaurant and bar. Typically those trees that are in front of the bar, these two trees, are 10 or 12 feet up on the grass bank. And I would say that probably right now there's a good 7-8 feet of water that isn't normally there. If you look at this little palm tree over here, the center of the screen, you would think it was just rubbish that floated down the river, but that palm tree is actually about 12 or 14 feet high, and it's standing in the water. So we're going to take a walk out on the bridge here. You can see lots of people on the bridge. You'd almost think it was a tourist attraction here, but I was here a little earlier to take some videos and forgot my my card, so I had to go back for it, my SM card. And what I found is that a lot of people are sitting here waiting for things to wash down the river that can be salvageable. So right now, as I mentioned earlier, people are going around telling people to evacuate from the river. Right now you can see there's a lot of debris coming down the river. The river is pretty brown, and normally this has got this river has pretty clear green colored water. So this is what's happening right now. A lot of stuff is washing down the river. The river is probably a good 50 feet wider than it normally is because it's washed up onto the banks. Pan around. See the water flowing down. The big tree you can see there is usually up on the bank, not in the water at all. And usually down below you can see the infrastructure from the old bridge. I'm standing on the new bridge. I'm not sure how new it is, but Usually there's pylons that stick 2 or 3 feet out of the water that were left there from the old bridge, but not now. I would say the water is a good 15 feet higher and apparently rising. Hey guys, it's the day after. It's for now Friday actually. The hurricane came through around midnight on Thursday night, and I'm back to the bridge that I took the videos of yesterday, and I'll probably post these ones ahead just to give you an idea of how much the river has dropped, or how much it rose yesterday. This is the pole where we could only see Vote, and it's already dropped a good 6 or 7 feet, and it's still got quite a ways to go down yet, but yesterday the water was right up to the underside of the bridge, so it is lowering. The river's getting back to normal, but it's got a long ways to go. I would say it's probably still a good 8-9 feet above the normal height. Okay, here we are on the bridge again where I stood yesterday, and as you look up the river, you see the narrowing there. That's normally the normal width of the river here. So you can see how much it's run up onto the banks. What used to be 30 feet wide is probably 100 feet wide here as it approaches the bridge. And we're going to pan around to where we were yesterday, looking over at the riverside. You can see the water has dropped a lot, but all of these trees and stuff that are out in the water now are normally up on the bank, and so you can see just how the rain is just as much a danger as the winds are in a hurricane. And this river comes out of Guatemala, so it would have collected all of the rain from Earl as it went through Belize, and as it passed this point into Guatemala, all of that water would have drained down this river. But it looks like things are receding, and there's probably not much danger of the road being flooded out anymore. Just one last shot at the river bank. I don't know if you can tell in this video or not, but you can see about 2/3 of the way up the grass bank the mud stains from where the river had risen to yesterday, and so it'll give you an idea of just how high it was.